Good morning, good afternoon, good evening guys, gals and gentlebods, and welcome back to the shed. And yes, we are in the shed. So, gearbox story. It's got a bit complicated. I'm going to try and keep this brief, because the one thing that annoys me when I'm watching YouTube videos from other people is a lot of waffle at the start. But I do need to just explain where I'm at and what's going on. So, in the last video, I'd stripped the gearbox. That was the second gearbox that I bought to rebuild so that I could put it straight into the car without disturb, so I could keep the car mobile, if you like. When I stripped it, I found that the second and third gears for the straight cut gear set, the bore in them was too big to fit on the main shaft bushes. Okay, put it all back together, take the gearbox out of the car, strip that, and I've got the same issue. That one doesn't fit either, for exactly the same reason. Now, if I had bothered to do some proper research on the internet and searched for the appropriate terms, I would have discovered that BMC and their infinite wisdom in the 60s used a lot of variations in the rib case gearbox. Different main shafts, different gear sets, different first motion shafts. Obviously the gearings all vary, but I didn't realise this. What I actually wanted was the gearbox for a late model 1275, possibly 1098 Sprite or Midget. What I actually got was a 1098 Morris Minor gearbox, and the parts don't fit. Now the gearbox out of the car turned out to be the same, a 1098 Morris Minor gearbox, so the parts still don't fit. So I rebuilt the first gearbox just to keep all the parts together so I don't get them confused with parts out of the second gearbox, and there is a problem with that gearbox. Third and fourth will not select. There is a problem with the synchro hub in that gearbox. I'd like to make it into a working gearbox, a little bit more on that in a moment. The gearbox out of the car that I've stripped now, I'm going to rebuild so that can go back in the car as it is. Because it is a good working gearbox, the only issue I had was occasionally it would jump out of first gear on hard launches. So I can live with that in the short term, simply by just holding the gear stick in first gear. I don't have to put any pressure against the forks to wear them out. Just hold it in first gear while it launches. I'm only in first gear for a couple of seconds and then change to second, and the rest of the gearbox is as sweet as a nut. It's just that the gearing isn't quite right for what I do with it, but it works. So I'm going to rebuild that gearbox. That box can go back in the car with the engine when I've built it. A little bit more on that in a moment. So the first gearbox, the one that I bought to rebuild initially, has got the problem, so I need to strip that, figure out what the fault is and fix it. If I can do that, I have a cunning plan to be able to use the straight cut gear set in that gearbox. I'll cover that in another video once I've got that gearbox stripped. Before I can do that, I need to rebuild this gearbox. I'm getting gearboxes left, right and centre at the moment. I could just hold out and try to get a Sprigget gearbox, but they're getting thinner on the ground, and mostly people want quite large sums of money for them. Having a quick look on the parts store, eBay, I'm seeing prices of 650, 700 quid for a box that probably needs an overhaul anyway. So there's another 120 quid's worth of bearings and gaskets, and all of a sudden I'm halfway to the cost of buying a fully reconditioned gearbox with the straight cut gear set in it. So, you know, I've got 500 quid's worth of gear set here and 120 quid's worth of bearings which I'll use on rebuilding the gearbox out of the car. Obviously not the straight cut gear set, but the bearings will. So there we have it. Anyway, so that's where I'm at with the gearbox. I need to rebuild this box so that I can put it back in the car. I'm not going to do that today. Today we're going down to the proper workshop, the big workshop, and we're going to make a start on building the engine. Now, if you may remember from a few videos back, I found I'd got a problem with the engine. I had the block bored because I got some plus 60 thou pistons, and the first cylinder they bored, it broke through into a little pocket of snot in the casting. Ruined the block. That's it. It's not, yeah, people have said line it. I could do, but the only liners I can find ready-made are to bring it back to standard bore. I need to go to plus 60, so I would need to have custom made liners, at least one custom made liner for that bore. That's assuming that the other three didn't break through into anything. That bore would need boring out quite a bit larger to accommodate the liner to be able to bore it back to plus 60 thou. Doing that, because it's on cylinder 4, would run a very high risk of breaking through into the oil gallery from the oil pump at the back, which, yeah, it's a known issue. It can be sleeved, but it's just adding cost and complexity to the issue. So I did some searching on the internet on the parts store, and I managed to find two 1100 blocks close to home at a very cheap price. So I bought those, picked them up. The only downside is they're transverse engines, not longitudinal engines, which means there is some machining and engineering work required to convert to a longitudinal engine. I'll detail that when we're down in the big shop with the engine. So I think it's time to go to the big shop. And just like that, here we are in the workshop. Right, I've got a bit of engine hurdling to do on this block because the transverse A series is slightly different to the inline A series. There are more bolt holes in the rear of the block for the rear engine plate on the longitudinal engine, the north-south engine. The crank is different, so I need to use the inline crank. I'll show you the difference in a moment. The rear crank oil seal is a completely different setup. There is no seal as such on the inline engine. What it is, there's an oil scroll machined into the crank, and there's a cap that sits on the top of it, bolted to the back of the block, and there's another cup that's part of the rear main bearing cap, which means that the transverse engine rear cap won't work for an inline engine. That means I've got to swap them. I've got to use the rear main cap off the old engine, which potentially gives me a problem because the three main bearings are line bored. That is, they're built up on the block and they're bored accurately in a straight line, so they're all in exactly the same plane. What that means is that the caps on blocks are not readily interchangeable. Right, so I've got my work coat on. Let's get started. First things first, rear main cap. Now, as I said before, they're line bored matched to the block. So typically, what I would need to do would be to assemble the three bearing caps on there and send that block away for line boring to match those three bores up. But I've been lucky. Just for once in my life, I've been really lucky, and when I've checked it, this is the bearing cap off the original block, the one that broke through in the machining, and that's just tapped down solid. When I've checked it, that bore is spot on. It's perfect dimensions to within a 10,000th of an inch, which in all fairness on an A series ain't going to make a big difference. It's not a full race engine, it's not the ultimate spec. So this is the cup for the oil scroll, so that sits on there. So I've drilled and tapped the 3 holes for that, so that will go on there. That surrounds the crank tightly, and the oil scroll on the crank will drive any oil that comes through the rear main bearing, will drive it back into the block via those 2 holes that come from within the cup. So that is good. I've got away lucky. There is still quite a bit of other engineering that needs doing to this block. Right, for one, this is the rear main bearing shell. So if I pop that on there, I'll just have to bring the camera in so that you can see this. Sorry about the wobbles. And as you can see, the oil hole in the bearing doesn't match up with the oil hole in the block. It's about 2/3 of a hole out, so that's going to restrict oil flow into the rear bearing, so we need to address that. So while I've got that in there, I'll just scribe around that hole. I need to take, what I need to do is elongate the hole in the block, not the bearing, because to make the bearing match the hole in the block would mean taking bearing material away, and I don't want to do that. These A series, it only runs in a 3 bearing crank anyway. We can't really afford to lose any bearing surface. So that'll be a job for the Dremel, or the Aldi equivalent of a Dremel. On this back face, this is where the back plate fits, and there are several more holes that need drilling and tapping around the oil pump area, and there's a hole that needs drilling and tapping in between those 2 for the dowel. So that's the back plate, that's the dowel in question. So that would sit like so. Now we have those 2, that one, and that one, that one, and that one. 1, 2, 3, 4. Yep. 1, 2, 3, 4 holes are missing in the block. So I need to drill and tap those. They need to be quite accurately done. And the hole for the dowel needs to be very precise, drilled and then reamed, so that dowel, it's a stepped dowel if you can see. So the wider part goes in the block and the narrower shouldered section goes through the back plate, and that aligns it accurately. Right, so I've double checked, and that dowel hole is on the same centre line as these 2 holes. So if I screw a bolt into each of those, that's obviously in that horizontal plane, and use a straight edge across there, scribe a line, straight edge there against those 2 bolts, scribe a line. So halfway between those 2 lines is the centre line. .9mm. Right, let's try that again. With a straight edge across there, side. And that's got it. Right. So I now have the centre line for that dowel hole. Now what I need to do is establish the distance between those two, because it doesn't help that this was built in imperial times in inch measurements and I'm using a metric caliper. Yep. Right. One thing I just need to check is that that hole is actually midway between. So which they are at 21.4 millimeters. So that dowel hole is central between those two. To punch, if you prefer. The reason for the dowel becomes obvious when you put the two bolts in because of the clearance around the bolt holes. Even though those are bolted down finger tight, there is a lot of movement in that. That's why I'm doing the dowel first. Right, so I've got my spot mark. I have to do a bit of engine hurdling to enable me to use the mag drill. That enables me to get a very perpendicular hole into the block. It has to be perpendicular to that face, otherwise if I tried to do it by hand and it was on the cock, the dowel could be like that. It ain't going to work. I've ordered a 3/8 hand reamer to ream the hole once I've drilled it. So I'm just going to put a pilot and an intermediate drill through it at the moment. I can go the depth of those bolt holes is approximately 17 millimeters. So I've put a mark on my drill bit at about 15. So we'll see how it goes. If this works well, we're on the right road. If it goes pear-shaped, I've just scrapped another block. Here goes. Oh, it looks a lot better. Right, let's change up to the intermediate bit. I will need to go to a slightly larger one before I ream the hole, but I'm going to wait until I've got the reamer to do that. There's no great rush. If I haven't got the reamer, I can't finish the hole, so there's no great panic over doing it. Unfortunately, what it does mean is I can't do a lot more today because I can't really locate to drill the other holes in this face without that dowel in place. So a little bit limiting. That's it, I think we've bottomed out. Obviously, once I've completed all of these drilling and tapping jobs, I've then got to thoroughly clean this block because these little chips of cast iron will get everywhere if they get into the oil ways and I don't clean them out. It's going to spell disaster for it. So still got quite a long way to go with this engine before it's ready to go back in the car. As I say, I can't really do the other holes until I've got that dowel accurately pinned, and then I can get this plate positioned properly and pilot the other holes. So I think the next bit that we can do just have a look at elongating this hole. Right, I'll have a go with a rotary tool. I shan't call it a Dremel because it's a Sealy. But all I need to do is just open that hole out this way, elongate it to the side to give full flow of oil into that bearing. Yeah, that looks pretty good. See if I can get you a closer shot of it. So now the oil hole lines up pretty well with the oil hole in the bearing. So we should get full flow of oil into the bearing. All good. Now one other job I do know that I need to address is the oil pickup. On the inline block, that screws into the block. On the transverse block, that actually lines up to the oil way in the gearbox casing, because on a transverse block the gearbox sits underneath it and acts as the sump. The gearbox runs in the same oil as the engine, which means that that hole in an inline block would be tapped to take that union. On a transverse block it isn't, so I need to establish what thread that is and get a tap for it. Probably have to open that hole out slightly to accommodate and then tap it so that that will screw in and clamp the olive nice and cleanly so that we get good oil pickup from the inline sump. So that's one I've yet to do. I doubt very much if I've got a tap that will fit that, and even if I have, I'm almost certain that I haven't got a drill to bore that out with. So this is probably a job for a week or so's time when I've acquired some more parts. Now when I bought Morty, the engine that was in it was supposedly a lightened and balanced, properly built engine with a big valve head and decent can and blah blah blah. When I've got it apart, these are the con rods that came out of it. And yes, I suppose any means of removing metal will lighten components, but is that really the best they could do? An angry chimp with a lump hammer and an angle grinder could have made a tidier job of that. Added to which, that one, the little end bush has come loose, that's worn. So basically, I was going to have a go at balancing and lightening these rods better. But in view of that little end, those 4 rods are fit for nothing more than the fucket bucket. So that's where they're going. which doesn't really matter because I managed to pick up a good quality set, good condition set of standard rods off eBay. I think they were about 20 quid for the set. I may lighten them, I might just leave them, just for the simple fact that I've never done that kind of work before, so I would be shooting in the dark. If I had bothered to, if those other rods hadn't got a knackered little end as well, I would have had a go at tidying them up, lightening them, balancing them. To be fair, I've put those on the scales, they're not even balanced. They're, I think the closest pair were 15 grams different. These four standard rods are actually, the heaviest of these is 10 grams lighter than the lightest of those. And these four, when I weighed them, I think they were all within about 10 grams of each other. So I may just leave them as they are and run them as standard. I may decide to lighten them and balance them, but that's a decision for another day. The block has been rebored 60 plus 60 thou. That's a standard piston, dished. That runs, I think the standard high compression engine was about 8 to 1, which isn't particularly high in this day and age. These pistons that I've got, they're 60 thou bigger, so the block's been bored to accommodate that, but they're flat top, there's no dish in the piston, so they will instantly give an increase in compression ratio. I'm hopefully expecting to get it up to around about 10 or 11 to 1, which would be good. That in itself would give a horsepower increase, more importantly a torque increase in the mid-range. But again, that's for another day. I need to get this block finished first. I can't do any more on that today because I need the reamer to ream the dowel hole. I need to sort a tapping drill and a tap to do the oil pickup point. I need to drill and tap the other bolt holes for the back plate. I think that's all there is to do on that, and then that block can be thoroughly cleaned and start to be built up. As I say, I need to decide whether I'm going to bother lightening the rods. On the one hand, I'm doing this much work, why wouldn't I? But on the other hand, if I make a mess of it, I could cause more problems than leaving them standard. So I've yet to make the decision on that. Anyway, that's about it for this video. There's not a lot more I can do. There's not a lot more I can say. So I think that's about it. All I can say is thank you for watching. I hope you found this interesting, maybe informative. If you have, hit the like and subscribe, notifications, all the usual YouTube nonsense, and I'll see you in the next video. Thanks for watching.